Hey, I think now audio should work.
From my crackers, mama?
Okay, sorry about that. I had to pause our recording for a second. I should be back on and I'm going to share my screen. And I just want to address a question. And then as I address this question, I'm also going to use my model to talk a little bit about railing structure and a few other things. So sharing and Hannah, I hope you don't mind. I'm going to share my screen with your question. Oh, where is it? Okay, here we go. So Hannah's question is actually really a good one in that it starts to get into the part where how is the structure supposed to be integrated with the spaces, right? And so here in this little snip that she sent me, the implication here is that the walls are inside and the columns are left on the outside of these spaces. And then, there's some issues here and whatnot. So that's one example of what can happen. And this other example, this is what happens when you go outside of your wall and then the columns are inside. So as I address this, and let me make sure that because sometimes that's so yes, okay. So so the idea here is that which one is better? And so the reality is that when we are dealing with columns in a building, more often than not, what's going to happen is that these columns are going to be encased or encapsulated in drywall. And that is because the columns very commonly need to be fire rated. And so one common way that we can achieve that is that we do what is known commonly as a column cover. A column cover is a set of studs. They're usually smaller and they're built around a column and then they are drywalled. And the idea is that they provide the fire rating that we need, the fire resistivity that we need for that column to not need fireproofing. It is not always the case that the steel column needs to be fire rated, but very often they are. And so one good way of dealing with columns is to quite simply think about them inside these square enclosures. And I will kind of find an example for you. Now, in this example, and I will need to find what that column cover looks like. In this example, what's happening is, clearly, these guys are outside, this one is inside, and then there is some, we need to deal with the columns in some way. And so I really appreciate this question because it is a very common concern that we have. So one way in this case would be that you could kind of create this kind of thing happening, right? And then these end up being like these recessed spaces along your back. And often in classrooms in particular, those are used for any number of things. Like if you look around spaces that you use all the time, you'll start to notice that there are these bumps and walls, and you may not necessarily think about, them that much, but they could well be these columns that are being encased. In other cases, we actually doubled the wall. And, maybe here you would do something like that so that when you're seeing this elevation, you would get some sense of symmetry. This could be infilled with a different wall material, and then that is your wall. Sometimes we use this to create the kind of entry that we need. So maybe you end up locating your wall right there. there's a side light or a glass light, sorry, and that is my wall. And so we're using this additional construction that we have to have in a meaningful way to create that. And that gives that a recess. So this is usually a pretty good way of using those columns. And so if you start looking at plans, you'll notice that architects are constantly finding different ways and different things to do with the columns. But the more common one is exactly what I mentioned initially, which is that we create a column cover. And so if you are interested in what that looks like,
Try my pizza.
okay. So I just searched for fairly common ones that we use all the time. So there are different ways to fireproof or give the resistivity that we need to steel. Steel is naturally not necessarily something that is going to catch fire. It will not ignite necessarily, but the high temperature caused by the fire can weaken the steel. And so the reason why we tend to want to cover it and keep it away from this heat is not so much that the steel is going to ignite and go down with the building as quickly, is that the heat weakening the steel means that your structure would be weakened, and that could mean that it fails a lot sooner, quicker, before all occupants can be safely exiting from a building. So typically when we are rating an element like steel, we rate in minutes. So we might say we need to provide a 1 hour, 60-minute enclosure or rating for an element. We can say that we need a 90-minute safety rating for a particular enclosure. Sometimes it's 20 minutes. So those ratings vary and they depend on elements, but typically because wide flange beams or any steel construction, it is a critical component to the building and critical to the building standing up, they are very often required to be rated in some way, very commonly 60 minutes. And sometimes in more strict occupancies, they would be rated all the way to 2 hours. And here in this page, you can see that after I search for that, here are different ways by which we go about that. Sometimes, and you've probably seen this in parking decks and other places, we might spray a fireproofing, which looks kind of like paper mache that is sprayed and encrusted on top of the member, and then the width and the thickness of that paper mache like fireproofing actually protects the column from failure up to a certain number of minutes. That is very common. Sometimes this is just not very attractive, so it is something that then has to be covered. And so when that happens, we take this column that is protected with this fireproofing that is sprayed onto the column. We take that and we create another type of enclosure. In this case, this example here is showing you how a fireproofing encased column is actually then wrapped in the drywall. So this is the wall itself. You can see the studs, and that's a layer of drywall, another layer of drywall, and then immediately around the column, and when with some degree of separation, a very clean sort of square like enclosure is created for the column, so that it is almost double protected. But this is much better to look at than the kind of paper mache kind of goop that you get out of your column. So in both of these examples, you know, this is using the fireproofing, the paper mache like fireproofing, and that's why you see it as kind of rough, as the principal protecting element to that column. There are other ways, because gypsum board is actually a fire rated material we can quite simply wrap a steel element, a column, a beam, any element that is made out of steel. We can actually create stud walls around it and then simply add as many layers of drywall as we need. In this case, this column enclosure is calling for a 1 hour to a particular size. And apparently to create this 1 hour in this particular setup, you need 3 layers of gypsum board. And so the gypsum is layered and close. And by the time it's all said and done, you end up with that fully encased in gypsum board rectangular column shape. And then this can be used to align to a wall on either the ends or the edges or to the center. And that is pretty typical sort of fireproofing and rating construction. And that is how usually we deal with columns in spaces. So I hope this is answering your question, Hannah. And then for everybody else who maybe hasn't gotten this far, it gives you another little way of thinking about this. So the other thing that I wanted to kind of talk about, since I have everybody here, I think my Revit crashed, so I may need to pause the video and resume in a minute when Revit opens. So quick pause, and I will be back. Okay, I'm back. Let's see. Share my screen again and keep going through this. So we were just talking about that example with the columns. So now I have our trusty sample model open, and I'm going to, what I've done, and I just play with this a little bit, but you can kind of see now that I have these wide flange beams that I put in here pretty generically, but they start to set up my structure. And then I also have the idea here is that I might start to use these walls that I created here as bearing walls. And so if you notice, I opted to use the 12-inch masonry that gives them a little bit of thickness. And masonry is a pretty good material. That also kind of gives me an option then to decide what the expression of my building is going to be on the outside, because I may not want these other walls to be masonry. And, that's something that I can play with. So right now, the way that I had started to think about this very, just kind of a model that I've been playing with in showing you things is that I tended to look at it in a way that I can do different things with climate. For example, if this wall is here and this is my bearing wall, and then I have this cavity on the west side here, then the idea was that this cavity would be able to help me shade the actual exterior wall. So in other words, I'm creating a buffer zone with this type of construction where I might run infrastructure, HVAC, I might put my stair towers in there, any number of things that I might do that can help me mitigate the heat gain. And so back to this idea of I talked about curtain walls the other day, and what I have here, this is the north side of my building. And I had thought that maybe having, these mud rooms, that's a really good idea before getting to your classroom. And so if these are my kind of young kids' classrooms, they could start to gain entrance and then come in here. And so I get to decide how I want to space those. It kind of depends on the elevation very much. And you know, I've provided these very generic looking doors. They don't have a frame or anything. And I put them in here. When we hang doors, a lot of people ask me, well, you know, where are you supposed to put the door? These that come from Revit, I always use the largest one that they have, but they don't necessarily show up with a frame or anything else. And we are at fine. So in case you don't know that, in Revit, you have 3 modes of displaying: fine, medium, and coarse. And depending on the element, sometimes certain elements won't show up until you go into a fine definition. And sometimes that can be like a door frame. So what I was getting to is I have my columns. They're right here. And I have a glass curtain wall that I pretty generically put in there. I have a few different ways that I may go about protecting and showing that column. One thing I'm acutely aware of is the fact that steel in a building like this starts to signify a thermal bridge. So what does that mean? When we have a steel member that is in contact with the ambience temperature on the outside, in particularly those that are exposed to direct sunlight, these fortunately would not be exposed to direct sunlight because they are on the north side and they're fairly well protected by this extension of this wall. So they will not get direct sunlight necessarily, but they will get heat, and they'll get heated up to the ambience temperature. And that temperature exchange will travel through the member and will be in here and will create a thermal bridge, what is known as a thermal bridge, which is to say that because the heat always wants to go where there's no heat, that heat is going to try and continue to go inside. And so because I know that, I may want to do something that helps me protect the steel member from doing that. And so in this case, one approach that I might take is the approach that says, you know what, I'm just simply going to use a partition type that allows me to, and in this case, it should be something exterior. So here are all the out of the box exterior. I'm going to go with the insulated metal panel. Really, EIFS is probably a better choice. You can go with brick, CMU that is insulated. There's any number of these. Let's just go with these. And so what I'm going to do is I'm going to create a very simple type of fin. And you can see that that's not exactly right because I will need to space this wall equally on both sides so that I can get away with that. And so what I'm going to say is I'm going to go with a foot on either side. That should work. So I'll make that a foot as well. And at a foot, it looks like that is actually clear of that. And so now what I'm going to do is I'm going to slice. I use the command slice so that I can break this. Let's get my little X-Acto right where I need it. And now I am going to pull my curtain wall into the EIFS wall. I'm going to unjoin it because it doesn't like it. And we're going to pull that one there. And so now that that's all done, I'm going to pull back this interior partition that I had. And so another thing that I may want to do is I may not want this element that I just created to be all the way in. So I'm just going to, it is okay. We won't need to delete the rooms. So what I've done is now I have like a pier and it's a protected column. I'm able to insulate that. And maybe I like that material coming on the inside. And so now I can repeat that for all three of my columns if I want to. And I might want to go to the outside and look to see what that looks like. And so you can see that in this particular case, this thing that I've made is basically right there. It's a column enclosure that I made. And so now if I want to deal with this curtain wall that encloses my mudroom, I can, you know, and that is not to say that the mudroom needs to be conditioned. I am conditioning it because the site is Phoenix. And so the mudroom is usually where the kids might come and put their stuff, like their lunch boxes and stuff. And so I don't think that I want to not condition this room. So I'm gonna put some panels here. You know, maybe this last one, we'll leave it alone at 7 feet. So you know, like what we did before. And maybe another one that is 4 feet. And then what's going to happen is that I'm going to insert a door in here. And I'm going to put some mullions and do some other things to make this. And this is my very big. Remember my friend, the mullion that I made that was very big? Maybe we don't want that guy. Maybe we want something a little bit smaller. We don't need a 16-inch mullion. A regular 2.5 by 5 would probably be more than adequate. And we're gonna put it here as well. And I'm gonna put it up here and here as well. And so it's starting to take shape. I would need to decide where my doors are. And I'm not gonna do that right now, but you guys get the picture. So that's one way of dealing with how that this will have to get put to right there. Yep. And so that's one way of dealing with that column in the interface at the glass. Another way of dealing with this column and the interface to the glass might be to say, you know what, I don't really want this column to get the heat. So the way that I'm going to deal with that is by simply providing or moving my glass line outboard or moving my column inside. So you can do either one. Right now, this is a 30-foot span, which works out really well. So let's just say for the sake of argument, this is what I'm going to do. I'm going to copy what I did right here. I don't know if you guys know this, but you can filter things in Revit. So the only thing that I want to copy right now is my walls. So I'm going to apply that and say, okay, and I am going to copy this. And this is going to go all the way to my end condition right there. And then I'm going to kind of do the same thing that I did before, which is that I sliced that. And we can come back and fix that. And so what's happening now is that I have these two fins, and we can see that when we go to the 3-dimensional drawing, or here, this part where we see the whole model, you can see what that is. And I can continue that and create a really nice rhythm with the columns on my facade, and then it would be glass and the glass would get interrupted, and that can be pretty nice. And I could have a third one here if I wanted to, but let's just say for the sake of this conversation, I don't really want this element repeating a third time here. I really want to deal with this one a little bit differently. Well, another way that I can deal with it would be to say, well, we're going to take this piece of curtain wall and we're going to move it. And I'm, in this particular case, going to get it out of my way by about a foot. And that should leave that column completely free. And it is. And it is okay. And so now that I have a column like that, like I mentioned before, you have to decide, are these columns needing to be fire rated or fireproofed? Or if they're allowed to be left exposed because we don't have that many occupants, then the column would probably be able to just stay. And then I could simply run my curtain wall right in front and have a small extension at the top of whatever this beam is so that I can actually capture it. So you would just go to the bottom of the deck and you can overhang your deck a little bit from the edge of the beam, which is right here. And that would be totally fine. And it might actually be a little cleaner than, for example, here, where there's a beam above this that then we would have to more than likely worry about. So what happens when we cut a section here and there is a beam? Let's see. So I'm going to put the beam. Okay, great. So I don't know where this is going to end up, but we're gonna put it. It's gonna say that it's not gonna show it, which is fine. And I always run my beams in segments, not continuous. And so this one column, we can actually delete that because it's in my bearing wall. I'm not using a column here because I'm actually bearing directly on the masonry, which is totally something that I can do. So let's see on the 3D, where are those beams? Where did you go, beam? And it is down here. Okay, so I'm just gonna grab them. And I'm clicking on my control key so that I can do plus, add all the columns to that. And then you can see here that it's basically by default putting my columns at level 0. I can't remember off the top of my head what my level height is, but I'm going to take a guess and say that I want these to go at 13 foot 6 inches. And you have to do both 13 foot 6 because this is the start and this is the end in case you need to actually have an angle or a slope on your beam, which is fairly common because we use them a lot on roofs. So in a roof application, you typically do need that. And so now I do have my beams up here and you can kind of see it. And you can see what that's starting to look like. So let's see when I push here a little more. Okay. So so this is the deck all the way above. This is saying it's a slab, but it cannot be a slab on deck. This should be more accurately a metal deck with concrete, like this one right here. So, or this one. Let's see what that does. So this is 3 inches of lightweight concrete on a 2-inch metal deck. This one is lightweight concrete on metal deck, not necessarily telling me what the size is. So the way that I would check, it's telling me it's a 5.5 thickness in total. And you can always go look at the structure. And what it's saying is that it's 1.5 inches of metal deck with a lightweight concrete that is 4 inches. So they're both about 5.5 inches. I'm gonna stick with this one. So what that means is that there is a corrugated metal deck that is put in place, and then the concrete is poured directly on top. And that's how this floor is constructed, unlike the floor that we poured on the ground, which is directly cast on the earth. So the beam is going to be directly responsible for carrying the load of this deck. So this metal deck sits directly on top of this beam. So I'm still a little bit low in terms of my height, I guess 13'6", and this is still a little taller. So I'm just gonna grab these guys and I'm gonna move them up to 14'6". And I mean, I'm still a little low. I may need to go dimension this just to see, but what is this, level 2? Okay, I made a 16-foot first floor, which is unusually tall. I don't remember making it that tall, but I must have. So the bottom of that is 15.6.5, and that's where I want to be. So now that I have seen that, you know, I'm just gonna set these. So in Revit, you know, that's kind of one fun thing, is that there's usually a lot of data associated with an element. So when you click on it, you can actually see it. 15.6.5 and 15.6.5 is where that wants to sit. And now it should properly be right at the bottom of this concrete deck. And that looks correct. And then you can see that this beam is connected to the column that we have put in there before. A lot of times, you know, we don't know exactly which one, if the column is going to go on or the beam goes directly on top. And it can be either one. It really depends on what we do structurally. More often than not, this will be at level 2 minus your the total of the structure, which in this case, it's 5.5 inches plus the height of the beam that I selected, which right now is a 12-inch. So it's basically 12 inches plus 5.5. So it's 17 inches, 17.5 inches. So if I click on this guy and I set the offset to be minus 15.5 inches, they say 15 or 17. Can't remember now. I think it was 17. So now that is sitting more properly where it goes. The way this works is that there's usually a plate at the top, almost like a capital, except that it is a plate for steel, and that plate is where the beams above will come and they get bolted into. And there's different ways of connecting them. But this is fairly common, that the column comes to the underside and then carries these on a plate. You would not model the plate. That's just not going to show up in this level of modeling. That would be a level of detail that it's a little beyond the scope of what you typically will see in a BIM model. But if you go then and draw a detail, you would then add those elements either by drafting them or in some cases by creating a detailed component that will show you that. So that's that. Now we have this, and now I'm gonna see what happens when I go left. So this is the column that I just adjusted to that distance. I can actually do a match properties. So match properties is MA, and then you can touch the one that you fixed, right? I'm gonna touch it, and then I'm gonna try and touch. It usually works for me. Let's see. So this is the fixed one, so match. Okay. That's not working so well for me, but it usually works really well. But minus 17.5. And that will do it. And you unjoin the elements. Oh, it's 500. Okay. It kind of sucks to do them all manually, but we'll do it. And so there it is. And the thing that I was trying to get to is if you see this, right? You see the relationship, you see what is going to happen. This glass would potentially butt the bottom of this beam. And so technically you would be able to do that, but you don't really want this beam to be what's supporting your glass necessarily. So the situation that this sets up is very much like the one that I was describing earlier, where then this beam, which is made out of steel, would be exposed to the temperature on the outside and it will travel all the way into your building. So a better setup for dealing with this would be to create a wall on the outside. And we're gonna look at that in a second here. I'm gonna go back to level 1. I'm gonna model this wall directly on level 1, but with an offset. And so the way that I would do that, and we can make it out of the same material that we modeled this enclosure, that would work. So let's see. Okay, so that's my wall. I'm going to move this wall to about right there. And I'm going to stretch it so that it meets this one. And so it would join that. And then I'm going to set the base offset. So we want this wall to actually be connected at level 2. I'm going to tell it to go all the way to level 2. That's what that means. And I also wanted to have a base offset. The base offset, I'm going to determine that by the height that I want my glass. In this case, I'm going to set my glass at 12 feet. So I'm going to say that the base offset for the wall is 12 feet. And then we'll go back. We'll see what happens here. And so what I'm trying to set up, and the wall will need also a top offset, or you need to attach it to here. And I'll show you what that means in a second. So this wall now is able to receive my glazing. My glazing is currently 14 feet. We're going to set it to 12 feet. It's a little bit more attainable of a height. And I am going to align my glazing to the center of my wall. And find a way to do it well. So I'm going to attach the top to that slab. And I don't know if you saw what I did, but I click on the wall and lets me attach it. That's good when you really know where something needs to be, because then it means that if I raise or lower the level of the slab, that wall is always attached to it. But I don't recommend it unless you know that for a fact. Okay. But it is very convenient. But you can see that now this exterior wall is kind of covering my, there is a stud that can connect here. There would be a clip that could grab this wall, and then this curtain wall can now move and be held from the bottom channel of this wall. So it's unrelated to that beam, and that's a more appropriate way of doing it. And so I'm gonna go back to level 1, and I am going to there's a few things that you can do. Maybe an easy one, and I'll use this in case you guys don't know this. I'm trying to do 2 things. I'm trying to show you kind of the proper way of setting this up, just in general, architecturally speaking, and then also maybe walk through some Revit things that you can do. So this view right now is a level 1 view, and I don't have an underlay on it. I can put an underlay, and it is very common that I will work with an underlay for a number of reasons. You can underlay any other view that you have in plan view on this one. So for example, in this case, we might say that we want level 1, but you want the underlay to be in the orientation of looking up. That's kind of like I would look up, and that's that can be convenient because then I will very quickly see the bottom of that wall that I just put in here, and you can see it there. Normally, we call that the RCP view, the reflected ceiling plan. So you can put any of these underlays, and you can see how useful that is, right? Like if I'm working in plan view and I need to be aware of where certain ceiling features are, where the beams are, where the lights might be, all of that, I can actually have that underlay, and then I can continue. And you can do the same thing. You can be working on a reflected ceiling plan where you're putting lighting, mechanical things, and you can put an underlay of the floor below you just so that you have that reference. And it's just very useful. So now that I have that underlay properly inserted in here, I'm going to take this and I am going to move it so that it lives about a foot away from where we originally had it and within the bottom of that wall. And you can see that's the beam right here, which is great. So if I had a ceiling in this area, I wouldn't see the beam, but maybe I want to leave it exposed. It's completely protected now, and that would be totally appropriate to do. And if I go to the outside, you can see what's going on, and it's pretty clear. Now, one thing, now that we have this, is that this extension on my slab, it's a little bit more than what I normally be okay with in terms of support for the distance from that beam to the edge of the slab. It's pretty great. Let's see, from here, that's like 6 feet. So that's a very big cantilever to do with just a metal deck. That's just not going to work necessarily. So in order for me to support this cantilever, this big of a cantilever, I would have to have some type of outrigger to support this. Either that, or I would have to move my balcony further out, not my balcony, but my mudroom, so that this beam is actually at a much more realistic, I would say 2 feet for a metal deck with concrete is about as much as you want to have. And so that you're aware, that's probably what I would recommend. I would take either this line of where this is out so that I can have a more manageable overhang, or I would cut this slab back a couple of feet so that I'm not completely. I had originally thought that I wanted these classrooms to kind of stack on top of these and project a little bit. And that can still happen, but I need to be mindful of the fact that if that's my beam line, I would need, my beam is connected to my column that is there, right? And so what happens is that if that is my beam line and I can drop it a little bit, and then if I drop it, we can have a potential for a member that sits here to take care of that cantilever. And then it would have to go back to another member in here, which wouldn't be the end of the world. We can probably do that. That's pretty doable. Or we can make this a bearing wall back in here, and we would just simply have these members projecting out. And they don't even have to go all the way to the edge, but they would project out to pick up the edge of this slab. And then we would need to cover that somehow. That's a perfectly doable condition. The alternative, which is what I was thinking would make some sense, is that we simply cut back the edge of this slab, kind of pushes in to where this edge of slab is no more than 2 feet. So I have that, and my beam is here, and that is fairly common to do. But when you start to have these floating edges too far out, that is probably not going to be so good structurally. So this is kind of more in the details of the structure, but you can kind of understand, I think, what's going on. And I've given you a few ways to address the sort of, column conundrum. The other potential way is that you simply leave your column inside, and if it's allowed to be exposed, you would put it on the inside, and you just run your glass, and your mullion would likely coordinate with that. And so let's just say, for the sake of argument, that's another one that we can do. And so we would just simply probably lower this to 12 feet, just like that other one. And we can go ahead and make this one also 12 feet. And within this, and that is about how many panels you may want to have. And then you can always kind of, Revit doesn't necessarily love dealing with these things in a 3-dimensional view. So let's just go back to our floor plan. So normally what I do, okay. So we can say to simply go equal, and those are going to be, all even sizes that kind of divide this into 4 panels on each one of these bays, which is actually pretty good. Yeah, so 5'7". And to this, we're gonna have to add some doors and other things. But instead of expressing this column, I have now decided that these ends are gonna have that, then these not so much. And then we can put the door in some of these panels can start to become doors. We can decide how to do it. I have a tendency not to like making the end panel the door, but that's just, that doesn't have to be that way. I just prefer to see the door more centered on my curtain wall. So these are double doors. I don't see necessarily a single one in the out of the box template. So I may have to, go find that. I don't want to put necessarily a double door on there. It's not wide enough for a double door, but you get the picture. I think you guys understand what's going on. And then, I got a little bit more into what needs to happen to make this building start to kind of look more realistic. And I think that was promoted by Hannah's original question is, how do I make the model reflect better how plants are really built and what their reality is. And so a lot of times is exactly that we need to start thinking about how things get trimmed, covered, concealed, and in the case of columns and beams, that is definitely something that needs to happen. And you can kind of see that here, you know, it would be possible for me to, you know, in this setup, use this enclosure to actually push those columns out. And let's see if in plan view that would help. So you see how I have a 30-foot bay here, but the reality is that I am actually picking up my intermediate members in this 24 dimension. I don't know if you guys understand what I'm saying, but basically I could very easily move now that column out further so that I can pick up that edge of the slab that I was talking about without much of a concern, because these columns, which are encased in my wall right here, could actually move with it. And if you look at my next bay, I have 27, so I have actually like 3 feet that I can still give forward to make that. And notice how I took a lot of care not to have any columns in the middle of my space. That is just not something that I want to have. So I could do that. I could just push this out, have my 30-foot span still met by pushing everything from grid line number 8 all the way there. And that's probably a really good solution. It might mean that I can't do this thing where I have glass right there. But if you notice, the only thing that I'm saving by doing that is it's really not having this enclosure. And is that really that bad? It actually can look very nice to have this kind of hierarchy of elements. And one thing that is often missing on the elevations is that there's no hierarchy of elements, because it's just the curtain wall and thin walls. And in this case, you would start to have, you know, the bearing wall, the beam, the column, and then you have these 2-foot piers that are really just covering the column. And that starts to get that hierarchy. So I think in this particular scheme, because my beams would be running what I'm trying to say right now, right? Like if this is 27, I have 3 more feet to move that column. So this could move 3 more feet, which then means that I can move that one 3 more feet and still have my 30 and have my girder and my girder here, another girder and a girder beam. And so those girders, then what they're doing is that they're getting my smaller members, likely not as often as that, but maybe every 6 feet, depending on how much my deck can span, then I would be putting these guys. And so that's a fairly short, very consistent span. The girder beam would be the deeper one, which is this one. And these guys would be a more shallow member. And that starts to be how I'm framing. These can go into something called a ledger. That is basically an angle that sits on the wall and receives that. And from here to here, if I needed it, I would transition it into a beam, a small beam to pick that up. And the same thing would happen here. And it does not matter that these purlins are not lining up with the walls inside, because this is all interior space. Even if the breezeway isn't technically interior space, it's all inside, and I can have a ceiling covering all of that. So it is not really critical that the purlins match exactly where the walls are. It's much more important, I think, that the girders start to match, because the girders coincide with your columns, and your columns need continuity. So in those cases, then you really do want to hold yourself to a more consistent interval. And so the framing of this is fairly clean and it's set up like this. And so everything frames into that, and it would do the same thing, would frame into this wall. And then anything that is kind of loose light, like so, would frame with an extension from this corner onto there. And then there's some other framing that we would have to do outside of those, but that would be kind of the principal framing methodology for this area. And then there would be, you know, another set of beams here to pick that up and continue. So, and then as we move to the other side of the building, on the south side of the building, we have set up a very different kind of floor plan. So the challenges here are a little different, and we would have to consider those. Right now, this says 39 feet. So the first thing that we'll probably do is say that that should be more like a 30, so that there's consistency of that distance. And that's where those columns would be. But the reality is that we don't need to do that. We can, in fact, at least in this floor plan, go to that line, and that's about 22 feet. Not a dimension that I like. So when I see things like that, I'm gonna say, you know what, that needs to be 24 feet. And you can see where that landed. So I'm gonna move this. I'm gonna move that a little bit out of my way here, doors to my auditorium. And I am just simply going to align my wall to that.
There you go.
And it shouldn't affect anything. It should still work really well. I have an exit door from my auditorium into the street and another exit door directly to the outside, in addition to the main entrance that comes from the lobby. There is the administration. I've now kind of rectified this error. I know I'm gonna need another grid line. So grid line number 10 here, you know, how is it set up? Let's see, right now it's 45 feet. I'm gonna enter 30 just as my default measurement, and that works because that's how I set that up originally. This is actually really, really good. Do I want a column here? Probably not. That's probably not a column that I'm gonna want to have. So this here would probably break my grid, the normative grid that I had set up, but I can have pretty much every other one. And this one, maybe what happens is that we just have an angled grid line to pick up whatever needs to happen with that edge. But just very quickly, that's how that works. This partition was set up as a generic 8. Normally interior partitions are more in hovering in the 5 to 6 inches and still have pretty good acoustics. So I'm gonna say that this one is a 6-inch partition, and you see how that column is poking out. As I explained before, that's probably not something that we want to do. So you get a choice, and in my case, what I'm going to do for this one is I'm going to deal with it by saying, so normally, again, pretty common to do this. And you would make that equal. So this would be a foot. And get in the habit of using your dimensions to set everything up. Oops. Must have entered 0. So 1. And so now that I've set that up, I can think about this as maybe that's the teaching wall. and it has all the technology incorporated into it. And of course, you can pull this back if you don't want it, and you can create another nook on this side. But typically, we can just have that bump out. If you think that that's not great, well, maybe you want to do a built-in here and do some storage, and then that would help keep that from becoming kind of a, you know, annoying, a nuisance in your space. There's multiple different ways by which we can go. If you thought that the better thing to do was to just generate the more normal column enclosure, you can always put one of those around that, and I won't go through the trouble right now of setting myself up with one of these. But if you did this guy, right, that's what that will look like. I tend to prefer this. There are going to be other things that are going to come into play that will need this. And in some cases, some people, you know, they're really so annoyed at that reality of the column that they just simply do this. You know, they just decide that they don't want to see them at all. And this is not necessarily that bad of an idea, because acoustically now the separation between these two classrooms is awesome, because you've created a really good air gap, and sound transfer would be a super mitigated by this big of a area. Now, the disadvantage of that is that you're basically giving up a lot of space. So usually my preferred way of dealing with this is that I can do one of these, and then what I might do is insert something in here that is like a component. I won't have something readily made, but typically what I like doing is, you know, I just want to say, just you have glass out here, I have this glass out here, and then I have this solid wall here. The intention is that this wall should at some point be partially at least glass, so that it can borrow light from that north side. It might be that it's lower, might be higher, but you know, definitely that there would be some ability to have glass and see the outside. But there would be probably a sink here so that kids can wash their hands, and then some type of bench or area where they can put their lunches, or like maybe cubbies, and they can put also their coats, personal belongings. All of that happens out here. You may start to think maybe that has to happen on this side, and then that means that you move the door so that you have more of an area of glass, so that you can actually borrow more light into your classroom. All of those things are things that we need to kind of think about. And then on the inside, what can happen is that we can start thinking of, you know, if this is the teaching wall, it's not the end of the world for sure that you have that, because then you would have, you know, maybe an area, this is all marker board potentially, and other things that you've seen, maybe technology itself can happen there. This wall can get drywall. Then how am I entering? It's probably through here. I generally like to set myself up for my circulation to be consolidated to one area. So that means that, you know, I'm furnishing this, and furnishing that, and then allowing that to come in and out and through my classroom. And then that would be mirrored on the adjacent classroom. And that's why that door is here, and so on and so forth. So anyway, just kind of a few things to think about as we're doing and continue to develop our projects. I hope, you know, some of these things are helpful. Let me know if anyone has any other questions, and I hope to see some of you tomorrow for the all section meeting.